Okay, Assalamualaikum and selamat sejahtera to all of you. Okay, so for today's lesson, we're going to discuss. Okay, so right now we're in chapter 3, periodic table, lesson 2. So for today's lesson, we're going to cover isoelectronic species, ionization energy, and also the electronegativity. Okay, so for the learning outcomes, okay, for this lesson, first is you should be able to define the term isoelectronic. The second, to compare the radius of isoelectronic species to analyze the variations in the ionic radius across period 2 and 3, to define the first and second ionization energy, and to analyze the variation in the first ionization energy across a period and down the group, to explain the increase in the successive ionization energies of an element, and define electronegativity and explain the variation in electronegativity of element. So for the explanation on the acid-base character of oxide for element in period 3 ni, saya nak awak baca sendiri sebab it's very straightforward. It does not have any, the explanation is not very long because it's very straightforward, just a few chemical equation. Okay, so we're going to start with the first part of our lesson is isoelectronic species, and you should know how to define isoelectronic species. Okay, so by definition, isoelectronic species is a group of ion containing the same number of electron. And isoelectronic species ini, sorry for the spelling, hanya ada satu E je. Okay, so for isoelectronic species ni dia hanya untuk ion. Okay, so maknanya if the ion contain the same number of electron, then we call it as a isoelectronic species. And normally, normally isoelectronic species dia boleh form daripada element of the same period. So let's take a look at this example. So saya ada element, the first 4 element in period 3. So ada sodium, magnesium, aluminium and silicon. Okay, if you look at the number of proton for each of the element is different because the number of proton is specific for each element. However, in order to form ion, the only changes occur at the number of electron. So kalau awak nak form ion, hanya number of electron je sahaja akan berubah. So maknanya kalau kita nak form cation, which is a positive ion, we need to donate electron. The number of the proton remain the same. In order to form an anion, we need to gain electron, but the number of protons still remain the same. If you look at this, the first 4 elements in the period 3, so the number of proton for sodium is 11, magnesium 12, aluminium 13, and silicon 14. However, when sodium lose 1 electron to form the stable sodium ion, Na+, the number of electron akan jadi 10. Magnesium, in order to form Mg2+, which is the most stable ion for magnesium, so daripada 12, dia remove 2 electron, dia akan jadi 10. Aluminium remove 3 electron, it become 10, and silicon remove 4 electron, have 10 electron left. So ini yang kita panggil dia sebagai isoelectronic species. Maknanya ion itu mempunyai number of electron yang sama. So we can say that sodium ion, magnesium ion, aluminium ion and silicon ion are isoelectronic species because they have the same number of electron. Okay, so same goes for negative ion. So for example, phosphorus 3-, S2-, and Cl-. All these 3 elements are located in the same period and they have different number of protons. So phosphorus have 15 proton, sulfur have 16, and chlorine has 17. However, when they form an ion, they're going to have the same number of electrons. So phosphorus will gain 3 electron. Okay, so the total number of electron of phosphorus ion is 18. So dia akan jadi 18. For sulfur, sulfur asal dia ada 16 elektron. So the gain 2 electron, the number of electron dia akan jadi 18. Chlorine asal dia ada 17 elektron and we gain another 1 electron, to form Cl minus, and now the number of electron is 18. So what we can say is P3 minus, S2 minus, and Cl minus, they are isoelectronic species because they have the same number of electron. So, sekarang ni awak kena tahu macam mana nak explain the trend in the ionic radius of 4 isoelectronic species for period 2 and period 3. Saya hanya akan tunjuk for period 3 sahaja sebab explanation dia sama je, awak hanya menggunakan konsep yang sama sahaja. Okay. So for isoelectronic species, okay, so macam mana nak explain the trend in the ionic radius for isoelectronic species with 10 electron? Okay, so the first thing we need to explain is we need to state the similarity. So the similarity is sodium, so awak kena state so Na plus, Mg2 plus, Al3 plus, and Si4 plus isoelectronic species with 10 electron. So electron tu nanti awak tulis electron sepenuh Saya hanya tulis dia sebagai E, ataupun awak boleh tulis dia punya electronic configuration dia sebagai 1s2, 2s2, 2p6. So macam yang saya ajar sebelum ni, before awak explain something, first thing is awak kena state dia punya similarity. So awak dah state similarity, baru kita boleh explain dia punya differences. Okay, so the difference between these four ion adalah kalau awak tengok dekat number of proton dia. Na11, magnesium 12, aluminium 13 and silicon 14. So awak boleh buat. So the number of proton of sodium ion is less than magnesium ion, is less than aluminium ion, and is less than silicon ion. So we know that the nuclear charge is directly proportional to the proton number, and effective nuclear charge is directly proportional to the nuclear charge and also proton number. So maknanya lagi tinggi proton number, nuclear charge increase, effective nuclear charge pun akan increase. Sebab apa kita guna effective nuclear charge? Sebab sekarang ni kita nak explain the trend across period. Ingat macam saya ajar dalam atomic radius. Kalau nak explain the trend across period, kita akan guna in term of nuclear charge. Nah, kenapa kita tak guna shielding effect? Sebab the shielding effect for element in the same period is the effect is very very small and it almost negligible. So when the number of proton of sodium ion is less than magnesium, less than aluminium, less than silicon, so kita akan explain dia punya nuclear charge. So the nuclear charge of sodium ion is less than magnesium ion, is less than aluminium ion, is less than Si4 plus. So when the kita kena ingat nuclear charge is directly proportional to the ZF ataupun effective nuclear charge. Maknanya lagi tinggi nuclear charge, lagi tinggi lah effective nuclear charge. So kita explain pasal effective nuclear charge. So the effective nuclear charge of sodium ion is smaller compared to magnesium ion, is smaller compared to aluminium ion, is smaller compared to Si4 plus. Okay, so macam yang saya cakap sebelum ni, effective nuclear charge juga dia akan effect dia punya force of attraction between the valence electron and also the nucleus. Okay, so dia adalah directly proportional to the force of attraction. Okay, yang ini yang awak kena ingat. Saya tulis je lah FOA. FOA itu adalah force of attraction. So antara keempat-empat ni, yang mana yang ada force of attraction yang paling weak? So kalau kita tengok, effective nuclear charge of sodium ion is weakest compared to magnesium ion, aluminium ion and Si4 plus. So we can say that the force of attraction between the valence electrons and nucleus of sodium is weaker compared to magnesium ion, and weaker compared to aluminium ion is weaker compared to Si4+. So when the force of attraction between the valence electron and nucleus become weaker, so sekarang ni valence electron tak tertarik sangat dengan nucleus. So what we expect is the ionic radius of sodium ion will be larger compared to magnesium ion, larger compared to aluminium ion, and will be larger compared to Si4+. Si4+, okay, between this isoelectronic, Si4+ have the smallest ionic radius. Sebab apa? Sebab the effective nuclear charge of Si4+ ni is the strongest. So the stronger the effective nuclear charge, then the stronger the force of attraction between the valence electron and nucleus. So maknanya valence electron tu akan makin lama akan makin tertarik oleh nucleus. That's why lah Si4+ ni in term of isoelectronic species, dia ada the smallest ionic radius. Okay, this one is for the positive ion. Okay, kalau kita tengok untuk negative ion pula, kita nak comparekan P3 minus, S2 minus, and Cl minus. Okay, so similarity dia adalah, kita tulis, P3 minus, S2 minus, and Cl minus. Okay, isoelectronic species with 18 electrons. Okay, so lepas state similarity, kita boleh start state dia punya differences. So for this one, the difference is in the number of the proton. So the number of proton for P3 minus is less than S2 minus, is less than Cl minus. So when the number of proton increase, so does the nuclear charge. So I explain pula pasal nuclear charge. So the nuclear charge for P3 minus is weaker compared to S2 minus, and S2 minus is weaker compared to Cl minus. So nuclear charge increase, effective nuclear charge pun akan increase. So the effective nuclear charge of P3 minus is less than S2 minus and is less than Cl minus. So when the effective nuclear charge increase, lepas tu kita akan explain pasal the force of attraction. So the force of attraction between the valence electrons, so valence electrons and nucleus in P3 minus is weaker than S2 minus and Cl minus. Okay, so kalau awak tengok sekarang ini P3 minus have the weakest force of attraction. So maknanya valence electron tu tak tertarik sangat dengan nucleus. So kalau valence electron tu tak tertarik sangat dengan nucleus, so maknanya dia punya radius dia lagi besar. So the ionic radius of P3 minus is greater than S2 minus and greater than Cl minus. Itu sahaja untuk isoelectronic. Okay, so now we go further into the next part of the lesson, which is ionization energy. Ionization energy kita dah briefly belajar waktu chapter 2, which is waktu kita belajar ionization energy for hydrogen. Okay, so by definition, ionization energy ataupun short form dia adalah IE is the minimum energy required for the complete removal of 1 mole of electron from 1 mole of gaseous atom in the ground state, and the value of the ionization energy must always positive. Okay, sebab apa positif? Sebab kita kena absorb energy. Okay, so macam yang saya cerita waktu chapter 2. Okay, so contohnya kita ada nukleus. Okay, ada nukleus, lepas tu kita ada orbit. Okay, kita ada orbit. So let's say lah, okay, sini ada 2 elektron, sini 1 elektron. Okay, so sekarang ini between the valence electron dengan nukleus, sebab valence electron adalah charge negatif dan nukleus adalah charge positif, sebab dalam nukleus kita ada proton. Okay, so between negative charge and positive charge kita akan ada force of attraction. Okay, sebab ionization energy ini adalah kita nak kick elektron itu keluar daripada atom. So kita kena make sure elektron tu ataupun valence elektron tu dah tak ada dah influence daripada nukleus. So cara kita nak kick elektron tu keluar adalah by supplying energy. Dan the value of energy supply must be equals or greater than the value of the force of attraction. So contohnya, ni sebagai contoh, ini bukan value sebenar. Contohnya value force of attraction dia adalah 20. So in order to kick the valence electron from the atom, awak kena supply energy sama dengan 20 ataupun lebih daripada 20. So that electron tu kita boleh completely remove daripada influence dari nukleus. So itu yang kita panggil sebagai ionization energy. And that's why ionization energy ini adalah positif sebab energy absorb. So macam kita tengok di sini, kita tahu. So when the force of attraction between the valence electron increase, okay, size akan decrease kan. Sebab apa? Sebab lagi kuat attraction daripada valence ke nukleus. So valence electron tu dia akan tertarik makin lama makin dekat dengan nukleus. So size dia makin lama makin decrease. So lagi kuat force of attraction, lagi susah. Okay, lagi susah awak nak remove electron. So lagi susah awak nak remove electron, the first ionization energy ataupun IE dia akan makin lama makin meningkat. So kalau force of attraction awak berkurang, size makin besar. So size makin besar maknanya valence electron tu dah tak di-influence sangat by the force of attraction daripada nukleus. So lagi senang awak nak kick elektron itu keluar daripada atom. So IE dia akan makin lama makin menurun. Okay, ini yang awak kena tahu konsep dia. Sebab tu saya cakap, macam lesson itu saya cakap, once awak dah faham konsep force of attraction dan juga atomic radius, lepas-lepas tu awak dah boleh dah explain the trend. Tak kisahlah electronegativity ke ionization energy ke, sebab dia berkait rapat dengan force of attraction and also the size. Okay. Ni macam saya cakap tadi. So atom with low IE, so lagi rendah IE maknanya lagi senang kita nak kick elektron tu. So lagi senang kita nak kick elektron, so maknanya lagi senang dia nak form cation. Okay, atom with high IE which is harder to remove electron. Okay, maknanya lagi susah kita nak kick elektron, so maknanya lagi senang dia nak form anion. Okay. So maknanya kalau atom with low IE, so macam saya cakap tadi, low IE maknanya dia ada force of attraction dia lagi weaker. So kalau force of attraction lagi weaker, so lagi senang kita nak kick elektron, so lagi senang dia nak form positive charge. Maknanya dia suka je dia nak donate dia punya elektron. Atom with high IE selalunya force of attraction dia lagi kuat. So force of attraction of the valence electron lagi kuat, lagi susah awak nak kick elektron. So tapi kalau force of attraction dia lagi kuat, dia senang nak attract elektron dekat diri dia. So sebab tu dia senang form negative ion. So negative ion adalah anion. Okay. So since dalam satu atom kita ada more than one electron with exception to hydrogen. Hydrogen hanya ada satu sahaja elektron. Atom macam sodium, helium, chlorine, phosphorus, dia ada banyak elektron. So if the atom have more than one electron, they are possible to have a multiple ionization energy. So dia boleh jadi ada IE1, IE2, IE3, IE4 and so on. So that's why the way we want to define the first ionization energy, okay. So it's defined as the minimum energy required to remove the first electron from gaseous atom in its ground state. So first electron itu perlu di-remove daripada gaseous atom in its ground state. Dan macam cakap tadi, the value of IE must always be positive sebab dia involve the absorption of energy to kick the electron from the atom. Okay, so sekarang ni kita tengok dia punya trend dulu. Okay, kita tengok dia punya trend. Okay, kita tengok across period. Macam saya waktu saya ajar atomic radius, kalau kita nak explain the trend across period, dia mesti berkait rapat dengan Z ataupun nuclear charge and also Z F ataupun effective nuclear charge. Okay, so dia sama je, tak kisahlah mana-mana period 2 or 3. Okay, across period, okay, across period from left to right, okay, the value of nuclear charge increase. Sebab apa value of nuclear charge increase? Sebab number of proton akan increase from left to right dalam periodic table. So when the nuclear charge increase, so does the effective nuclear charge. So macam yang saya cakap tadi, so number of proton increase, nuclear charge increase, effective nuclear charge increase, force of attraction akan increase. Ini yang benda ni yang awak kena faham konsep ni. Okay. So maknanya across period from left to right, now the effective nuclear charge increase. So when the effective nuclear charge increase, so the force of attraction between the valence electron and also the nucleus become stronger. So maknanya sekarang ni valence electron tu is held more tightly to the nucleus. So makin lama dia makin rapat dengan nucleus. So maknanya nucleus tu ada influence yang besar terhadap valence electron tu. Okay, so when the force of attraction between the valence electron and nucleus become stronger, so now it is difficult to remove the first electron across period from left to right. Thus the first IE will generally increase across period from left to right. So across period from left to right, IE akan increase. Sebab apa? Sebab right now the force of attraction between the valence electron and nucleus become stronger. So lagi susah awak nak kick elektron, so lagi susah awak nak kick elektron, lagi banyak energi yang awak kena supply so that awak boleh kick elektron tu keluar daripada atom. Okay, kenapa saya guna perkataan generally? Sebab kita akan nampak few irregularities. Kita akan nampak dia punya anomalous case between 4 atoms. Sebab generally, kalau general trend dia akan increase, tapi ada few anomalous case. Okay, so contohnya, ini saya ada gambar rajah, okay, the IE versus atomic number for element across period. So, element across period tu. Okay, so macam saya kata tadi, generally, okay, generally the IE will increase. Okay, IE will increase. Itu yang kita tengok sini. So, IE the generally increase from lithium to neon. Okay, tapi ada irregularities. So, the first irregularities happen between beryllium and boron, and the second irregularities happen between nitrogen and oxygen. So maknanya irregularities itu ataupun anomalous case itu akan berlaku between group 2 and group 13 and group 15 and group 16. Sebab kalau tak ada anomalous case itu, kalau tak ada, kita expect boron dia punya IE dia akan lagi besar daripada beryllium. Same goes with oxygen. Oxygen sepatutnya IE dia akan lagi besar daripada nitrogen. Tapi sebab apa? Okay, sebab kita tengok dia punya orbital diagram. Macam mana kita susun elektron itu dalam orbital. Okay, so mula-mula kita tengok irregularities between beryllium and boron. Okay, so the expected IE1 for boron should be higher than beryllium. Tapi actual IE1 for boron is less than beryllium. Sebab apa? Sebab kita tengok electron valence tu berada dekat orbital mana. Dan orbital tu macam mana stability orbital tu. Okay, for example, beryllium. Beryllium is an atom, okay, an element with 4 elektron. Okay, boron ada 5. So kalau kita isi elektron dalam orbital for beryllium, the valence electron for beryllium will occupy 2s, while the valence electron for boron will occupy 2s and 2p. Okay, so nak remove electron, kita kena remove electron from the highest energy orbital. Okay, for the beryllium, the first electron will be removed from the 2s. Okay, untuk boron, the first electron will be removed from 2p. So kita tengok stability dia. 2s untuk beryllium ini adalah fully filled 2s orbital. 2p orbital dalam boron adalah partially filled 2p. So macam kita tahu, fully filled is more stable than partially filled. Okay, than partially filled orbital. That's why lah the first IE for beryllium is higher compared to the first IE of boron. Sebab apa? Sebab the first electron, okay, in order to get the first IE for beryllium, the first electron must be removed from the fully filled 2s orbital. While for boron, the first electron need to be removed from the partially filled 2p orbital. And we know that the fully filled 2s orbital is more stable than the partially filled 2p orbital. So the more stable the orbital, then the more energy that you need to remove the electron. So lagi banyak energy awak perlukan nak remove electron daripada fully filled 2s orbital compared to the partially filled 2p orbital. That's why lah the first IE for beryllium is higher compared to boron, which is dia lain lah daripada kita punya expected. Sebab kita expect boron ini akan lagi tinggi dia punya first IE. Okay, same goes between nitrogen and oxygen. The irregularities can be explained by using the stability of the orbital. Okay, nitrogen is an element with 7 electron while oxygen is 8. Okay, so kita tengok, okay, the valence electron for nitrogen involve 2s and 2p. Same goes with oxygen, 2s and 2p. Okay, however, the first electron in nitrogen, okay, kita tengok 2 must be removed from 2p. And the first electron for oxygen need to be removed from also the 2p. Tapi kita tengok, okay, ini adalah half fill 2p. Ini adalah partially fill 2p orbital. So we know that half fill is more stable than partially fill 2p orbital. So maknanya elektron, kalau awak nak dapatkan first IE untuk nitrogen, kita akan remove the first electron from the half filled 2p. While for the oxygen, we need to remove from the partially filled 2p. So half filled 2p orbital is more stable compared to the partially filled 2p orbital. So macam saya kata tadi, lagi stabil orbital itu, lagi banyak energi yang awak perlukan. Sebab lagi susah awak nak kick elektron itu daripada atom. That's why lah nitrogen will have higher IE compared to oxygen. Even kalau kita expect, kalau kita ikut general trend, oxygen itu sepatutnya ada lagi tinggi IE compared to nitrogen. Okay. So, variation down the group. Okay, down the group dia tak ada irregularities. Okay, macam kita belajar atomic radius, down the group kita akan compare in term of the value of n and also the number of inner electron. Okay, lagi ke bawah, the principal quantum number akan increase. Okay, so going down the group, the principal quantum number increase. So when the principal quantum number increase, the force of attraction between the valence electron and the nucleus become weaker. Sebab apa? Sebab number of inner electron tu makin lama makin bertambah. So when the number of inner electron increase, the shielding effect will also increase. And now, so the valence electron now is more shielded. So maknanya dia dah tak rasa sangat nuclear charge daripada nucleus tu. So now the valence electron is now further away and held loosely by the nucleus. So kalau ada held loosely, maknanya lagi senang kita nak kick elektron itu keluar daripada atom. So now it become easier to remove the first electron, hence the ionization energy decrease down the group. Sebab apa? Sebab lagi senang kita nak remove elektron itu daripada atom. Okay, so dalam sebab periodic table ni adalah chapter assignment. So chapter assignment, so nanti awak boleh refer balik lah notes itu untuk buat assignment. Okay, macam saya cakap tadi, since most element ada more than one electron, so we going to have a multiple IE. So kita ada first IE, second IE, third IE and so on. Okay, tadi kita dah define first IE, so now we need to define the second IE. Kalau first IE, the electron are removed from the gaseous atom, tapi second IE is the electron are removed from the gaseous ion. Sebab nak remove electron, kita kena remove step by step. Dah remove first electron, baru kita boleh remove second electron. Dah remove second electron, baru kita boleh remove third electron and so on. Okay, so the second IE is defined as the minimum energy required to remove the second electron from a positive gaseous ion. Okay, so and then ingat macam cakap tadi, the second IE, the electron must be removed from gaseous ion and still the IE is positive sebab this process is involve absorption of energy. Okay, so when an electron is removed from neutral atom, okay, electron mutual repulsion akan decrease sebab number of electron decrease. Tetapi the number of proton remain constant dalam atom tu. So elektron kurang, number of proton bertambah. So attraction makin lama makin kuat. So kita akan expect the second IE ini akan lagi besar value dia compared to first IE. Reason dia sebab apa? Sebab the value of Z ataupun nuclear charge tu makin lama become stronger. Dia remain constant sebab kalau kita nak form ion, kita tak usik proton, kita hanya usik number of electron. So kita akan expect first IE akan energy lagi rendah daripada second IE. Second IE energy akan lagi rendah daripada third IE. Third IE akan lagi rendah daripada fourth IE and so on. Okay, reason dia sebab apa? Sebab lagi banyak elektron yang awak kick, lagi kurang dia punya elektron mutual repulsion. Tapi proton number remain constant, so makin lama elektron tu akan makin tertarik ke nukleus. So force of attraction besar, so lagi banyak energi awak perlukan nak remove elektron itu. Okay, so dan kita boleh menggunakan maklumat daripada IE ini untuk determine atom itu ada berapa banyak valence elektron. Okay, so kita tengok So contohnya sodium. Okay, sodium ada 11 elektron. So contohnya sodium, so electronic configuration dia adalah 1s2, 2s2, 2p6, 3s1. So the first IE of sodium must, the first electron of sodium must be removed from the 3s orbital because this is the valence electron. So the first IE is 496. Okay, kalaulah kita nak form Na2+. Okay, kalau kita nak form Na2+, the second electron need to be removed from the 2p. Dan kita tengok 2p ini bukan valence electron. Okay, 2p ini kita panggil dia sebagai inner electron. So inner electron dia akan makin located nearer to the nucleus. So makin dekat dengan nucleus, makin tinggi force of attraction. So makin tinggi force of attraction maknanya lagi banyak energi awak perlukan nak kick elektron tu. That's why lah kita tengok beza first IE dengan second IE untuk sodium dia ada very drastic increase. So kalau awak tengok data tu, once awak nampak drastic increase between the IE, tu maknanya elektron tu mesti di-remove daripada inner electron. So contoh macam magnesium, the first 2 electron need to be removed from the valence 3p, daripada valence 3p. Tapi kalau awak tengok, nak remove elektron ketiga tu, the IE tu dia have a huge jump daripada 1451 dia terus melonjak kepada 7000. So kalau awak nampak a huge jump between the IE, maknanya IE itu mesti elektron itu mesti di-remove daripada inner elektron. So daripada data ni kita bertengok, sebab first IE and second IE difference dia tak banyak, dalam 700 macam tu je. So difference dia tak banyak. So kita boleh cakap yang the first 2 electron is removed from the valence shell. Tapi kita tengok IE third. The third IE dia melonjak daripada 1000 kepada 7000. So 6000 dia punya energy yang kita perlukan, perbezaan energy tu. So that's why kita boleh conclude the third electron itu di-remove daripada inner electron. Sebab apa inner electron? Sebab kita nampak huge jump between the IE. So contoh lain macam phosphorus. Phosphorus, the first 5 IE ni beza dia tak banyak sangat. Dia punya jump tak banyak. So antara 1000 hingga 1009 around 900. Ini around 1000. Ini around 2000. Ini around 4000. Tapi kalau tengok IE6 dia, so dia terus melonjak sebanyak 15,000. Dia huge jump. So maknanya kita tahu IE6 itu mesti datang daripada inner electron, sebab kita tengok value IE tu. Dia ada banyak, dia meningkat secara mendadak. Okay, contoh yang macam ini. Contoh macam ni, macam mana kita nak tahu valence electron daripada successive ionization energy tu, kita tengok Okay, kalau awak tengok maklumat ini, awak boleh tahu the huge jump itu occur between IE5 dengan IE6. So huge jump tu berlaku antara IE5 dengan IE6. Kita boleh buat conclusion. Di mana the first 5 electron ini datang daripada valence electron. Sebab dekat IE6 ini yang ada huge jump, kita boleh concludekan di mana the 6 electron must come from the inner electron. So maknanya atom ini hanya ada 5 valence electron sahaja. Okay, selalunya kita akan buat conclusion. Okay, kita boleh buat conclusion since the highest jump occur between IE5 and IE6. Okay, we can conclude that the atom consists of 5 valence electron, and the 6 electron, is removed from the inner shell. Okay, so kalau kita tengok selalunya kalau dari nak dapatkan data valence electron, nak tahu berapa banyak valence electron daripada IE ini, kita hanya boleh conclude S dengan P block sahaja. Reason D block, sebab D block between element itu, sebab kita ada sebab electron tu dah start fill up D orbital. And electron in D orbital, dia punya shielding tu ataupun dia punya effective nuclear charge tu is almost negligible. And then kita tak boleh discuss successive IE menggunakan D orbital. Sebab apa? Sebab the value dia lebih kurang sama je. Awak takkan nampak huge jump dalam D orbital. Okay, so kita boleh conclude yang elemen ini, so this element have a valence electron of NS2 and P3. Sebab kita tahu hanya P block sahaja yang ada 5 valence electron. Sebab S block the valence electron can be either 1 or 2. The rest tu mesti p block. And then kalau period berapa ni kita tak boleh tahulah sebab tapi selalunya soalan dia akan cakap elemen itu dia dalam period apa. Okay, so this element is located in group 15. So kalau awak buat conclusion ini selalunya conclusion ini markah dia adalah 1. Okay, conclusion ni markah adalah 1. Tapi kalau awak nak tengok ayat lengkap dia ada dalam notes. Saya tulis ayat lengkap dia. Okay. Okay, so settle IE kita masuk electronegativity. Okay, by definition, okay, electronegativity is the ability of an atom to attract electron towards itself when covalently bonded with another atom. So maknanya lagi tinggi electronegativity tu lagi senang dia nak tarik elektron dekat diri dia. Lagi senang dia nak tarik elektron dekat diri dia. So maknanya IE tu makin tinggi. Lower IE bermaksud dia susah nak tarik elektron dekat diri dia. Itu kita panggil dia sebagai lower IE. So IE ini juga dia berkait rapat dengan atomic radius dan juga force of attraction. Okay, so so proton number increase, Z increase, ZF increase, force of attraction increase. So electronegativity pun akan increase sebab dia lagi senang nak tarik elektron. Okay, ini kalau kita nak explain for across period. For down the group, okay, untuk down the group, okay, the principal quantum number increase. Okay, so the number of inner electron increase. So shielding effect akan increase. So when the shielding effect increase, so force of attraction akan decrease. So when the force of attraction decrease, so the electronegativity will be also decrease. Sebab kalau force of attraction lemah, lagi susahlah dia nak tarik elektron dekat diri dia. Okay. So trend electronegativity. So across period from left to right, electronegativity akan increase. Down the group, electronegativity akan decrease. Okay. So kita tengok explanation dia. Explanation dia sama je macam atomic radius dan juga IE. Okay, across period, okay, proton number increase. So proton number increase, nuclear charge also akan increase. So lagi besar nuclear charge, lagi besar dia punya effective nuclear charge. So the stronger the force of attraction. Sebab the force of attraction is directly proportional to the effective nuclear charge. So when the force of attraction becomes stronger, so it's easier for the valence electron atau for the nucleus to attract electron dekat diri dia. That's why electronegativity dia akan increase. Okay, so kalau down the group, principal quantum number increase. So lagi banyak principal quantum number, lagi banyak dia punya inner electron. So lagi banyak dia punya inner electron, the shielding effect dia akan increase. So shielding effect increase, the force of attraction dia akan decrease. So distance between the valence electron and nucleus itu akan increase. So maknanya sekarang ni attraction tu kurang, so lagi susah dia nak tarik elektron. So lagi susah dia nak tarik elektron, electronegativity dia akan decrease. Okay, itu sahaja untuk chapter ni. For the acid base properties, itu saya nak awak baca sendiri sebab it's very straightforward. Okay, so for the next lesson, we're going to discuss tutorial question. Okay, thank you everyone.